Hello everybody, we are Group 5 and we're going to be showing data visualization with Python. Alright, so the lesson structure for today was we'll be showing how to do the basic installation, so we'll be using Anaconda, and then Seaborn, Pandas, NumPy, and Jupyter Dashboard, which are all packages within Anaconda. And then we're going to be showing just the basics of Jupyter Notebook, and then how to connect to datasets. And then the graphs we'll be showing you guys how to make today in Python are box plots, histograms, regression plots, and then we're going to be showing how to do some basic dashboarding in Python using Jupyter dashboards, and then of course outlining what the assignment's going to be. Alright, so we're going to be showing installation. So first, like I mentioned before, showing Anaconda and then showing how to import the packages. Alright, so if you go to the Word document that we link in the GitHub, go to the first link and that's going to open up the Anaconda website. So when you open it up, the web page is going to default be on the Mac operating system. So if you have a Mac operating system, go ahead and download Python 3.7 installation. And if you're Windows, go up and click on the Windows icon to the left of the Mac operating system icon, and then choose a download based on your operating system, either 64-bit or 32-bit, and let it download. It will take a little bit. So once it's finished downloading, you go ahead and click on it and open it up and just follow the prompts like I'm doing here. Next. Okay. And so here you're going to want to make sure you check the first box. It is going to light up red when you do it. But that's something we definitely want to do. And then you're going to continue following the prompts, and the installation again is going to take a little bit. Alright, so then when it's done, you're good to close out of this. Alright, follow the prompts still. And check both of these. Alright, and then you can go down to your search bar, Anaconda Navigator. Alright. Again, everything takes a little bit with this, but be patient. Alright, so now we're going to show how to download some of the packages that we'll be using in Jupyter Notebook. So if you type in Anaconda, you can see the Anaconda prompt. So we're going to open this up, and the first thing I'm going to show is what happens when you try to install something that's already installed. So NumPy, Seaborn, Pandas already come with the base Anaconda. But if you go here and follow the instructions that we link in the Word document, and type that in, alright, so it's going to run and do its thing a little bit. Alright, as you see, it says that the requirement's already satisfied. It returns that it has it. Alright, so next we're going to show installing Jupyter dashboards, which is something that we don't have every section of, or every part of. So go ahead and type in what's written under Jupyter, and it's going to just show those lines of code. So pip install Jupyter_dashboards. Go ahead and type this in, hit enter, and we say collecting. Okay, it's going to run and do its thing. Alright, and you see some of the packages that were already satisfied, but some they had to collect. And then we're going to type the line of code underneath it for the quick setup. Okay, Jupyter dashboards, quick setup, and just follow that line of code exactly how it goes. Okay, it's going to run and do its thing as it does. Alright, so now we're going to quickly just run you through some of the basics of Jupyter Notebooks, which is the IDE we're going to be using. So when you open up Anaconda Navigator, go to Jupyter Notebook right there and just hit launch. It's going to load, and it's actually going to open up your web browser. It's just a local web page you see up there. So you go to the top right and you click new. You want to click on Python 3 and it's going to open a new Python 3 notebook. Alright, so this is what Jupyter Notebook looks like, and we're just going to go ahead and name this something other than just untitled. So let's name it Test Notebook. Alright, so the cool thing about Jupyter Notebook is it's kind of like these little containers, so when you run your code, it just runs like that line of code, and it's not this, it's a little easier to do test code or little lines you want to, so if you want to show, right here we're just going to show print, so you do print and then parentheses and hello, and then you see underneath it prints out hello. Then here's another example, print hi. There you go. So that's a little example of what kind of Jupyter Notebook brings. And also something useful is the ability to write comments. So you can let's type in here, this is a comment, and if you do Shift Enter and run the code, it's going to give you a syntax error. But if you want to make that a comment, you can go up to the top and select Markdown instead of Code, and then you do Shift Enter. And see, it's just going to be a comment within Jupyter Notebooks. Alright, so that was just some kind of a quick introduction to Jupyter Notebooks. Next, we're going to show you how to connect to data sets, do a little web scraping, and then just some other cool things you can do within it.
Alright, so we're going to do a little bit of web scraping now. We're going to start by importing all of our libraries. And how you know that all your libraries will get imported is by that little asterisk in the little top left corner. It'll disappear. So we're going to start by getting our website that we want to look at and assign it to a variable. So in this case, we're looking at NFL records. Then we're just going to open that up real quick. Alright, so now that we have it open, we're going to locate our data and then simply select it all and Control-C, copy to clipboard. Then we're going to go back and we're going to type in a line of code that's going to it's going to read what we have copied down, and we're going to also assign that to a variable. Now that we have that, we're going to run it. And as you can see, all of the data that we copied has been now imported into Python. All right, so from there, we're going to see what columns that Python automatically assigns to this data set. And we're going to take a few of those out, and we're going to assign those to a data frame, and we're going to work with those separately. So in this case, we're going to work with the columns 1 and team. What's important here is to mind the spaces that are after team and 1. If they're not included, then it won't be read properly. Okay, so now that we have that, we're just going to run it. And there we go. Okay, so from here, I'm going to show you how to make a simple bar graph. And it's as simple as just one line of code. It's not going to be very clean, but it works. And there we go. It's as simple as that. So we're going to clean this up a little bit. It's a little bit messy, like all the values aren't in order. So we're just going to put that into ascending order. Okay, so we get an error here, and this goes back to what I was saying earlier about mining the spaces. If you can see from that error message, the issue is that there is no space after team. So once we add that in, then Python recognizes it, and there you go. Now the teams are ordered in ascending order.
All right, so now we're going to show how to import data from an Excel file. So obviously I'm going to open another Jupyter notebook. Go ahead and import the NumPy and Pandas libraries. Okay. So now we're going to point to the right Excel sheet. So Excel equals pd.excel file. And then in here, you're going to do single quote and you do GPA data dot XL SX. All right, so that's the name of the Excel file. And then this right here, data equals Excel dot parse, and then single quotes data, which is going to be the sheet from the Excel file that we're pulling from. All right, so you go ahead and run this. All right, and now data, and it's going to print out what is in the Excel file. So one important thing when you're pulling from an Excel file in Jupyter Notebooks and Python is you want to make sure that you have the Excel file in the right location. So you're going to make sure you have the Excel file in the same place that you're saving your Jupyter Notebook files. So you see there I have the GPA data, and then you see I have the entitled Jupyter Notebook file. Alright, so the first chart that we're going to show you guys how to create is a box plot. So here you're just loading, or importing the libraries rather. No mistake. Alright, so first we're going to just generate some random data to show you how to make a box plot. See right there, just generate 100 random points of data and type in the symbol out of code right there. And then see it creates a fun little box plot. Alright, so now we're going to just show another example of creating another box plot, but we're going to create data. So you're still creating random points of data there. That's center. All right, now we're going to create the last one. Flyer low. All right. Okay. All right. So now we combine that, and then we're gonna. So now we're gonna start plotting the next box plot. Add a little S there. All right, and now here, and the title. All right, so as you can see there's a more complex box and whisker plot. And I'm going to show there's some other things that you can do to kind of change how it looks. So I'm going to do here is I'm going to just set notch equal to true, and then it makes it a notched box and whisker plot. So there you go, run that, and you see those little notches there on the edges. And then next we're just going to change the color of the outlier points, the flyer points. So we're going to create a variable. All right, and now in a similar way that we did the notches, we're just gonna in the code that you create the box plot, you're gonna set flyer props equal to the variable data, which is green diamond. All right, run that, and you see there that the flyer props are now green and diamond shaped. It's a neat little thing. All right, so now that we just showed you how to kind of create box plots using just generated data, we're going to show you how to create a box plot based on data from an Excel sheet. So we're going to use the same Excel sheet that we used in the earlier portion of the video. So after we're going to go ahead and import the Excel sheet, or at least point it to the right Excel sheet, and of course it's called GPA data like last time. Right, and then we're going to create a variable again, call it GPA data. Now we're just gonna run the variable creators to make sure that we imported the Excel file correctly. So just gonna run it. Actually, we're gonna pull out the GPA section from the Excel sheet that we imported. So you see it called GPA.grade. So grade is actually the column that holds GPAs. So we set that equal to X, so it's easier to create box plots. The single column. This is me creating. So call it figure 2 and X2 because we already created a box plot under a different name. All right. I'm gonna go ahead and just set the title. Set to student, GPA. Let me see, we're setting box plot equal to that, or using the variable X, which has our GPA data to plot, and then we're just setting the labels as GPA. So there we go. Create a quick little box plot utilizing the data that we pulled from Excel. Alright, so now we're just going to show how to make a histogram. So first we're going to start obviously by importing our libraries. And then we're going to generate random data as we did with the box plot. Right. And as with the box plot, it's a fairly simple line of code to create a histogram. Just put dataset 1, which is our randomly generated data, and then it outputs a little histogram for us. So now we're going to generate 2 sets of data and show how we can have 2 histograms in the same on the same scale, or on the same chart rather. So if you have dataset 1, which is 100 random data points, and then we have dataset 2, which we just generated with 80 random data points. Now we're just going to go ahead and plot these. So you see right here, I set after dataset 2, I put a comma and I created the color Indian red, and actually did not put an equal sign. So make sure to do that. So Indian red is just the name of the color in Jupyter Notebook or Python. So see there, that's just showing the second histogram. So now we're going to go ahead and we're going to combine the 2. Right. And we're going to set this one to sky blue. And we're going to set the alpha to 0.5, and that just kind of sets the transparency. I'm going to set the bins to 20. Now we're going to go ahead and plot the other dataset 2. So putting them in within the same box in Jupyter Notebook, for lack of a better word, is going to plot them on the same line, or the same chart. Then we'll set this one to Indian red as well. Set the alpha again, 0.5. Set the bins to 20. All right, and then run that. And you see now we have them over top of each other, and it kind of creates a little purple color where they overlap. An example of kind of what happens when you change the alpha, it just makes it more solid. So it's a little harder to read it like that. But you can play around with that depending on what you want to represent in your histogram. All right, so now we're going to generate some more random data. And just kind of show how to use Seaborn, because the two different libraries have different ways of doing it. And it just creates a kind of neat graph. When I run it, you'll see what I'm talking about. It creates a histogram with like a scatter plot. In between, it compares the two different data sets on the outsides of it. So obviously, this is just showing that you can utilize many different charts to create, visualize the data however way you want to. I'm just going to show another variation of the same thing I just ran. It's just going to be similar. Join plot. Data 1. Data 2. And then set here, we're going to set kind. We're going to set it equal to hex. So hex is just a different kind of chart. So you'll see when I run it, you see in the middle, it's a hex chart. So there's just some kind of more neat things that you can do. Just kind of, again, showing how much you can really do with this, even though we're kind of just touching on the basics. But there's tons you can do with this. So next we're going to pull in our Excel data like we did with the box plot, and we're going to show how we can use the data that we've been working with to create a box plot. File. All right. Now again, we're going to set X to our GPA column, which is going to be GPA data.grade. This is a good example of what happens here. It has to make sure that name column the correct name, because I put it as GPA, and it was in reality it's grade when you ran it. Then you no longer get the error. And then just X and show that there's the list of the GPAs. All right. So I'm going to go ahead and we're going to start creating our histogram. All right, let's go ahead and plot. So you put in whatever name you name your variable that you assigned to the GPA column, or in this instance it's the GPA column, but obviously if you're creating another chart it's going to be whatever data you're trying to work with. There we go, we're going to set the bins. And so this right here, we're setting the bin values. So it's going to make it so the bins are going to be in the ranges that I listed. So the GPA to be 1, 1.5, 2, 2.5, 3, 3.5, and 4. And at the end here, to see edge color, that's just making it so the borders around the histogram bars are going to be black. Because as you saw in the earlier examples, there's no really clear breakage between the lines. And again, that's just another tool you can do. This isn't necessarily required. It's just for what we're trying to do, we want the bars to be a little more clearly visually separated. All right, and then here we're labeling the X axis. We're naming it GPA, and the Y is going to be number of students. Now I was going to set the title. All right, and then here you see. All right, so we're setting the range of the y-axis. It's a little easier to show once the histogram is plotted, but I have a little bit of a syntax error there. I have a little happy accident, yeah. Looks like I have some parentheses mixed up. All right, and now you see we successfully plotted it, and you see on the y-axis, you see that the numbers range from 0 to 11, like the range that we set previously in the code. And then you see in the bars are separated with bold black. All right, so now we're going to show you how to make regression plots. So we're going to start in a new Jupyter notebook, and we're going to start by importing our libraries. All right. Get rid of that little S. All right, so we're going to create a regression based on data that we can just load from Jupyter Notebook or the Seaborn library. Okay, we call it tips. All right. There we go, SMS.plot. So right here we have x equals total bill, which is going to be one of the column names in the data, similar to how GPA or grade was the column name. And tip is also another column name. And then we're saying the data set equal the data equal the tips, which is the data set that we loaded. All right, have a little extra parentheses. All right. And now you see we ran a regression, so we should have a regression plot on it, and you can see that has a line of best fit, and it actually puts the axis labels on. You have tip and then total bill. And then here I'm just like showing you what data set we're pulling from. You can see that we don't utilize every single column when running it. We're just comparing two of the variables together. All right. I'm just again showing a little extra stuff that you can do. Put a comma after tips, and then you can see that you set marker equal to, and I've set it to the plus character, and you see that now all the data points are now represented as plus signs in the regression plot. And there's more you can do with it, but I'm just giving an example of how you can kind of change it. And of course, there's a wealth of things, but I'm showing you some of the more simple things. All right, now we're going to do a regression plot based on the data that we were using in the past two charts. All right, so getting ahead of myself. Data. All right. Make sure I pull up the right sheet here. All right. So now we're gonna run our. We're gonna create the regression plot. So in the past ones we set GPA, specific column grade, to X, but in this one we don't have to do that because within the line of code we're gonna set X equal to the column that we want. So X is going to be equal to grade data, which is what we set our data from the Excel sheet as. And we're going to do grade, so that's obviously our GPA column like we used in the past. And then we're going to do comma. And then we're going to set Y equal to grade data dot HPWS, which is hours per week studied. And then set data equal to grade data. Run that. Ooh, little error. Okay, that's a pretty simple one. I put an M instead of an N. Alright, and as you can see, regression plot on that is hours per week studied on the y-axis, and then it has GPA on the x-axis. So it helps show the relationship between hours per week studied and the student's GPA. Alright, so we're setting the range of the y-axis. It's a little easier to show once I actually once the histogram is plotted. But I have a little bit of a syntax error there. I have a little happy accident, yeah. Looks like I have some parentheses mixed up. All right, and now as you see, we successfully plotted it, and you see on the y-axis, you see that the numbers range from 0 to 11, like the range that we set previously in the code. And then you see the bars are separated with bold black. Alright, so we're going to just introduce dashboarding a little bit, just quickly touch on it, show some of the more like a higher level overview of everything. So as with all the other ones, we want to start by importing our libraries. So get the matplotlib one, and then get Seaborn there. Then we have the next one, which is a widget one. Alright. Alrighty. So just like we did with the regression one, we're gonna go ahead and load tips from the Seaborn library. And that's just gonna be the data that we're gonna work with when I'm just showing you how you can utilize dashboards. Okay. And then this here, I'm going to show you, just kind of give you, I think I showed you in the last one, but I'm going to go ahead and show you what data we're working with. So I'm just going to do tips.head, and it just shows the top 5 entries in the data set. Just kind of gives you an idea of what we're looking at. So now we're going to go ahead and we're going to mess around with the dashboarding. So really follow what I'm following. So we're going to go interact, and then hue equals, I'm going to put brackets, and we're going to put smoker in there. So see how it corresponds to that column, and then comma. I'm going to put in sex, and you get another column in there. And the next we're going to do is time, and then day. Alright, let's make sure everything's looking good before I move on. Alright, so now enter yes colon okay underscore equals sns dot pair plot tips u equals u. Alright, so now what you see is this generated basically a dashboard. You see a lot of the same charts because it just kind of generated 9, and it just did some of the more default ones. You see multiple. Oh, actually ran again. You see 2 of the same of most charts of all the charts, and then 1 extra chart. Basically, there's just a lot you can do with this with dashboarding. And you go up there. Actually, what the interact did is it created a drop down, so you can select between different variables that are showing in the dashboard. So you see you hit time, and sometimes it's a little subtle in some of the changes, but if you look, and then the biggest change you're going to get is when you go and change the drop down to day, because there's more day variables. So you see obviously there's like 4 different possible days. So there's definitely a lot that you can do with the dashboarding. This is just kind of a super high level overview of some of the more basic things. But there's a ton you can look up and find that you can do and play around with in dashboarding.
After all that, you might be wondering why Python is a better tool to use for stuff like this rather than Excel. So I'm just going to go over a couple basic points. First, it's great for cleaning data, as you may have seen through some of the previous clips. There are more options for graphs compared to Excel, such as box plots and whatnot. Get really creative with it and really customize your graphs. You can avoid version control. So when working with Excel, oftentimes on bigger projects, you will make multiple copies of whatever you're doing just to avoid, screwing things up totally. So using Python is a good way to avoid all that. You can load, clean, wrangle, analyze, and plot data all in one place rather than using multiple worksheets. And additionally to that, Python does not touch the original data. So you can avoid making multiple copies with slightly different variations in the data, just for the purposes of your worksheet. All right, so I'm going to introduce you guys to the assignment real quick. The objective here is to create a Jupyter notebook and import the included Excel file called gym. With that, you're going to create a histogram, a box plot, and a regression plot. The important thing here is that you save your Excel file wherever you save your Jupyter notebook. So make sure those two things are in the same place. Otherwise, it won't import properly. This data set contains 30 records for people who go to the gym, and it tracks their weight loss as well as the total time they spend in minutes. And you're going to want to look for correlation, if there is any, and then explain it. So towards the end of the notebook, include a cell with a comment, just explaining what you found and any potential reasons for the correlation or lack of a correlation. And towards the end, I've included a list of potentially useful libraries and imports. You're going to use some of them you won't need. It just really depends on how you want to go about this.